Hi guys, this is day 11 of the A2 Economics Revision Challenge, and today we are doing paradox of thrift and the accelerator theory. Paradox of thrift tells us the impact of saving in an economy. Like if people save, they will increase consumption possibilities in the future. We say actually saving is good in an economy because when the saving goes up, this becomes what we call funds for investment. So when some people are saving, that's good for an economy. In fact, poor countries' biggest problem, one of the biggest problems, is that there is sometimes what we call a saving gap. A saving gap is basically the idea that poor countries do not save too much because they have a high MPC and a low MPS. So that's why we feel that some people saving or some proportion of an economy saving is good, because that saving that is done is funds for investments. The saving happens in a bank, and then that those banks will then lend to sort of organizations for money for investments, and that basically lowers the saving gap. But paradox of thrift says is that, what, if some people save, that's not bad because that is increasing consumption possibility in the future. But what if all the members in the society decide to save? And if all the members in a society decide to save, this may not be good, this may not be desirable, because that increase in saving by the society means that there will be a decrease in consumption and aggregate expenditure. So what we're saying is this, that if saving goes up, consumption goes down. And if consumption goes down, AE is equal to C plus I plus G plus X minus M, AE falls. And when AE falls, we say this, that this via the multiplier leads to a more than proportionate decrease in national income. So when AE goes down, then what we say is this, that via the multiplier, your GDP also falls. So that is not good for an economy, because things don't stop here. Because what is happening here, because of this fall in GDP, now we will see the firms will realize that the demand is shrinking in the economy. So the next step for the firms will be they will cut down investment. So what we are implying is basically the idea that lower consumption can then lead to what we call firms to be discouraged to invest, and this discouraging business confidence or low business confidence is also going to hamper or also going to affect the GDP of the economy. How? So we say this, when the I goes down now because of the lower consumption, AE will fall further, and when AE falls, via the multiplier, you will see another fall in Y. So there will be another fall in Y that will happen, and so a reduction in income will result in a further decrease in income, and that is not good for the economy, because this decrease in income means that this rise in saving has caused what we call an economy to fall into a recession. So what we say basically is this, that when the first saving goes up, consumption falls, which makes the GDP fall, and then investment goes up, investment goes down because firms are finding demand to go down, which further causes Y to go down. And this all means the economy will fall into what we call a recession. So what is paradox of thrift? Paradox of thrift is simply the idea that higher saving can lead to lower national income. And it's called a paradox because savings should be good. Savings should be resulting in more income for the future. But it is contradictory with when everyone saves, it actually ends up lower consumption and therefore lower investment and therefore lower GDP and lower economic growth in the future. So not everyone, or basically the idea that everyone together should not save. Some people saving is good for the economy. Now I want to show this in terms of a diagram as to how this can be shown through our AE curve. So we'll make two diagrams here. First diagram is where A is equal to Y diagram, and the upper diagram is your A is equal to Y, and the lower is W and J. So initially we start off by making our Y equals to AE line, which looks like this. hits the 45-degree line. And let's say right now our incomes are very high, equilibrium income is very high somewhere here. Okay, so this is my AE naught, and currently our equilibrium income is Y naught. Now this Y naught is meeting in the lower graph as well, where my withdrawals are simply here like this. Let's say this is my withdrawal right now, and my investment is, for example, or my injections are, for example, here. Okay, so this is our initial situation. We are at Y naught, we haven't started saving. Now let's say savings begin, or people start to save more. When saving go up, consumption will fall. So the first thing will happen is when the consumption goes down, AE falls. So I will make my AE to fall to, for example, AE 1, and this fall in AE is happening because consumption is going down. Now in the lower graph, now my GDP, by the way, now is going to be not Y naught but Y1, but in the lower graph, or with the same injection, now I'm saying my withdrawals or saving will go on. Remember, withdrawal is basically S plus T plus M, and injection is I plus G plus X. So right now withdrawals are going up because people are saving more. So in this graph I'm going to make my new withdrawal function, which is going to be like this. From W it's going to become, let's say, W1. So my new equilibrium moved from point A to point B because now I am basically saving more. So this is basically saving going up. Saving is going up here, which means consumption is going down here. Now firms, when they react in terms of lower demand, we said this, that when the A falling, there will be a reduction in I, which will further means AE falls, which will further lead to a fall in GDP. So there will be again a fall in AE from AE1 to, for example, AE2, but this time around we have Y2 here, but this time around our withdrawal function are such, so this is Y2, that our, let me zoom this, that our AE has fallen all the way, or GDP has fallen all the way, because now the injections have gone down. So I will make my new function here where my current GDP is going to be at Y2, for example, primarily because now my injections has gone down, because this is a fall in investment. So you don't need to make so many graphs, by the way. You can also show this in your exam through a simple A graph. First A is going down because consumption is going down, then A is going down because of investment going down. Even if you don't show the withdrawal function and injection function, that's perfectly okay. But I just wanted to explain the idea. So initial Y goes down because consumption is falling, and then Y goes down because investment is falling. So that is what we call the paradox of thrift. The paradox or the contradiction comes about where saving suddenly has become something not good but something bad. Our next discussion is about investment and accelerator theory. So far, we've been discussing the Keynesian model, where we've seen how in the Keynesian model, investment is autonomous, it's not a function of Y. But the accelerator theory has a different idea. It's not a Keynesian model, it's a different theory. It says this, that the level of planned investment varies with the rate of change of income or rate of change of output rather than the rate of interest. So basically this theory suggests is that when the GDP goes up, there is the possibility of income to go up. In the Keynesian model, basically investments was taken as autonomous, which means that when Y go up, your I was unchanged or I was constant. But in this model, we are assuming accelerator theory that GDP or output when it rises, there will be a rise in investment. And the logic basically is simply the idea that if there is more output, there will be need for more investment. So the accelerator theory is simply making investment as induced, which means a function of y or dependent on the rate of change of income. Now, there's one more thing that we want to talk about. It also assumes basically that that a change in income will cause what we call a more than proportionate change in investment, and they come up with this kind of an equation. They say this, that change in I is equal to alpha times change in y, where this alpha is simply what we call the accelerator coefficient, what we call sometimes the capital to output ratio. So this is another word or another name for this is simply what we call capital to output ratio. Now the idea goes this. Let me give you an example. Let me write this first, capital to output ratio. Let's give an example of this. Let's say your GDP is going up by, for example, or change in Y is, for example, 300. Now, if change in Y is 300, and let's say alpha in an economy, the capital to output ratio is for example 2, then your change in investment, according to the accelerator theory, will be 300 times 2 or 600. So the idea of the accelerator theory is this, that whenever there is a rise in GDP, there can be a possible rise in investment. In fact, there is another thing that they talk about in the accelerator theory, that if the GDP is rising at an increasing rate, then you will see I to rise. For example, what if the GDP is rising every year at a constant rate, let's say 3% or 2%, a constant rate, then according to the accelerator theory, investment will not rise, investment will remain the same. But if the GDP is rising at an increasing rate, this is where you will see investment to rise. Now, this concept is important in many ways, because we can use this concept and multiply it together as well. So let's talk about what we call accelerator multiplier interaction. So according to the accelerator multiplier interaction, basically what if I tell you, for example, let's say government decided to increase expenditure. So government, let's say, do expansionary fiscal policy. Well, if there's an expansionary fiscal policy, AE will go up. If AE goes up, then via the multiplier, let me write this, via the multiplier, we will see a rise in Y. Now, if this GDP goes up, you can imagine investment to go up. Why? Because this is what we call via the accelerator. Accelerator theory says this, that if the GDP rises at an increasing rate, and let's say GDP does rise at an increasing rate, then investment will go up. And if investment goes up, then automatically via the multiplier, because AE goes up and I goes up, AE goes up, then via the multiplier, you will see, let me write multiplier, you will see Y to go up. So there's a chain reaction that can happen because of what we call one single rise in AE. So G goes up, AE goes up, which through the multiplier made my GDP go up, which would mean if the GDP is rising at an increasing rate, you can see the accelerator to kick in, which can cause again investment to go up, and therefore AE goes up again, and therefore GDP goes up. This process is what we call the accelerator multiplier interaction.